U.S. Representative Anna Paulina Luna is not some random politician demanding space pictures. She chairs the House Oversight Committee's task force on the declassification of federal secrets. She has conducted multiple congressional hearings on unidentified anomalous phenomena since 2023. She has subpoena power. She can compel testimony. She can force data release. And on October 31, 2025, she sent a formal letter to NASA's acting administrator demanding 4 specific categories of data on Comet 3 I/ATLAS, with high-resolution HiRISE images topping the list. NASA's response? Complete silence. But when Kim Kardashian tweeted about the comet, NASA replied within hours, "No aliens, no threat to life here on Earth." A celebrity got an instant response. A congresswoman with declassification authority got ignored. On November 3rd, Luna went public on Twitter, tagging acting NASA Administrator Sean Duffy directly. Still nothing. Her formal congressional inquiry sat unanswered while the scientific community watched in disbelief. This wasn't protocol. This wasn't normal bureaucratic delay. This was a deliberate information blackout. Luna had been tracking this object for months. On July 29th, she consulted with Harvard astrophysicist Avi Loeb about 3 I/ATLAS. On August 1st, she initiated formal communications with NASA requesting data. By October 31st, patience had run out. The letter was explicit. Release the Mars Reconnaissance Orbiter images. The images that could answer every question. The images that NASA captured on October 2nd and then locked away. By November 5th, Luna confirmed publicly, "Just had a good conversation with NASA. They'll release images as soon as the government reopens." Except the government already reopened, processing resumed. Routine Mars images started flowing again, but not these images, not 3 I/ATLAS. 40 days and counting. The clearest view of an interstellar visitor in human history, captured by American technology, funded by American taxpayers, and now hidden behind closed doors. While China and Europe shared their data openly, Luna's demand set the stakes. This isn't about conspiracy theories. This is about transparency. This is about what happens when the most powerful space agency on Earth decides Congress doesn't need to know what it saw. October 2nd, 2025. NASA's Mars Reconnaissance Orbiter captured Comet 3 Y/ATLAS during its closest approach to Mars, just 18 million miles. The HiRISE camera delivered 30 kilometers per pixel resolution, the highest resolution view of any interstellar object in history, 3 times sharper than Hubble. A side-angle perspective no Earth telescope could match. The images exist. They were processed. Then they vanished into bureaucratic limbo. Standard processing time for Mars images? Days to weeks. Standard release time for high-interest astronomical targets? Immediate. When the first interstellar object Oumuamua passed through in 2017, observations were shared within days. Same for Borisov in 2019. For 3 I/ATLAS, 40 days and counting. Meanwhile, China's Tianwen-1 Mars orbiter observed the same flyby and released images within weeks, showing a coma diameter between 3,100 and 6,200 meters. Fuzzy but public. No hesitation, no delay. The European Space Agency's Mars Express shared their data immediately through standard channels. Over 50 facilities worldwide contributed observations. The James Webb Space Telescope published findings. Hubble released images. Ground-based telescopes shared spectra, all public, all transparent. But NASA's Mars Reconnaissance Orbiter, the one with the clearest view, the one that could reveal structural details no other instrument could provide. Nothing. The excuse? Federal government shutdown. The shutdown began October 1st, 1 day before the observations. Staff were furloughed. Human approval processes froze, except the shutdown ended. Processing staff returned. Routine Mars images resumed release. Images of dunes, craters, polar ice caps, all flowing normally through NASA's public data pipeline. But not 3 I/ATLAS. This asymmetry is unprecedented in modern astronomy. When New Horizons flew past Pluto, images were released faster. When Mars rovers landed, images appeared within hours. When the James Webb Space Telescope achieved first light, NASA couldn't share data fast enough. High-interest discoveries get priority. They get immediate public release. They get celebrated. So why, after 40 days, are the sharpest images of an interstellar visitor still locked behind closed doors? What did NASA see that required this level of control? The Mars Reconnaissance Orbiter's HiRISE camera is not just powerful, it's revolutionary. At Mars distance, it achieves 30 kilometers per pixel resolution. That means it can distinguish features smaller than a football field. For 3I/ATLAS passing at 18 million miles, this translated to unprecedented detail. But resolution is only half the story. The viewing geometry is what makes these images irreplaceable. Every telescope on Earth observed 3I/ATLAS from roughly the same direction. Looking up from our planet as the comet passed overhead, HiRISE captured it from Mars. A completely different angle, different lighting conditions, different perspective on the nucleus, the coma, the jet structures. This side-view geometry could reveal asymmetries, surface features, and structural details that Earth-based observations simply cannot detect. What could these images show? First, nucleus size. Current estimates range across a factor of 17, anywhere from 320 meters to 5.6 kilometers in diameter. HiRISE could constrain this immediately with direct measurement. Second, shape. Is the nucleus spherical, elongated, irregular? Natural comet nuclei are typically potato-shaped, tumbling chaotically. If 3I/ATLAS is perfectly spherical or shows geometric regularity, that would be scientifically significant. Third, surface features. At 30 kilometers per pixel resolution, craters should be visible if they exist. Smooth patches versus rough terrain. Any patterning, geometric or otherwise, would stand out clearly. Fourth, jet morphology. 7 distinct outgassing jets were detected from Earth, but remain poorly characterized. HiRISE could show exact emission points, angles, distribution across the nucleus. Are jets randomly placed as expected from solar heating? Or do they emanate from specific features in organized patterns? The images were captured. NASA confirmed the observations happened. The data was transmitted back to Earth. Processing began. And then, silence. No preview images. No preliminary reports. No scientific papers utilizing the data. Just a black hole where the most important observational dataset should be. Representative Luna's October 31st letter specifically demanded these HiRISE images as priority 1. The scientific community has been requesting access through normal channels. Avi Loeb publicly called for transparency. Yet 40 days later, we're still waiting to see what NASA saw on October 2nd. NASA's official explanation points to the federal government shutdown that began October 1st, 2025, exactly 1 day before the Mars Reconnaissance Orbiter captured its observations. Staff furloughs froze human approval processes. Science operations entered minimal mode. Data processing pipelines slowed to a crawl. It's a convenient explanation, it's also incomplete. The shutdown ended. Staff returned to work weeks ago. Normal Mars operations resumed completely. HiRISE images of Martian terrain started flowing through NASA's public data archives again. Images of sand dunes, crater formations, polar ice deposits. Routine geological observations returned to their standard rapid release schedule. The processing infrastructure recovered. The approval chain reactivated. Yet the 3I/ATLAS images remain withheld. This is not how NASA typically handles high-interest discoveries. When the Mars Reconnaissance Orbiter detected evidence of flowing water on Mars in 2015, the announcement came with images immediately. When Martian avalanches were captured in real time, data went public within days. High-interest targets get prioritized, not delayed. They get accelerated review, not bureaucratic burial. Compare this to China's response. Tianwen-1 observed the same October 2nd flyby from Mars orbit. Their images were lower resolution, but captured similar data. Within weeks, those images appeared in scientific publications and public databases. No shutdown excuse, no 40-day delay, just transparent data sharing following standard astronomical practice. The European Space Agency's Mars Express operated under no such constraints and released their observations immediately. 50 observatories worldwide managed to coordinate, process, and publish findings in normal timeframes. Only NASA, with the best equipment and clearest view, remains silent. Avi Loeb published a scathing piece on Medium arguing this delay is probably not a sign of extraterrestrial intelligence, but rather of terrestrial stupidity, emphasizing that science should not be held hostage to shut down politics. He's right about the politics being stupid, but the shutdown ended weeks ago. So what's the real reason? Is it bureaucratic incompetence? Reviewers dragging their feet while a historic discovery sits in limbo? Is it political sensitivity? Someone higher up the chain deciding these images need careful framing before public release? Or is it the images themselves, showing something unexpected enough that NASA is consulting with advisors on how to present the findings? Representative Anna Paulina Luna's involvement with 3I/ATLAS didn't start with angry tweets. It started with careful preparation. On July 29, 2025, she consulted directly with Harvard astrophysicist Avi Loeb about the incoming comet. Loeb had been tracking 3I/ATLAS since its July 1st discovery, analyzing its unusual trajectory and chemical signatures. He briefed Luna on the anomalies, the carbon dioxide dominance, the nickel emissions, the statistical improbabilities stacking up with each new observation. On August 1st, Luna initiated formal communications with NASA requesting data, not public tweets, not media grandstanding, formal congressional correspondence through proper channels. She wanted comprehensive datasets, spectroscopy, imaging, trajectory refinements, chemical analysis, standard scientific transparency. By October 31st, the Mars flyby had occurred and images were in hand. Luna escalated. She sent a formal letter to acting NASA Administrator Sean Duffy, listing 4 specific data categories, with the HiRISE images explicitly prioritized. The letter invoked her Oversight Committee authority and made clear this was not optional. Congress was formally requesting scientific data captured with public funds. NASA's response? Ignore the Congresswoman, reply to the celebrity. On November 3rd, Kim Kardashian tweeted about 3I/ATLAS. NASA's official account responded within hours with reassuring platitudes. No aliens, no threat to life here on Earth. Quick, friendly, public. Meanwhile, Luna's formal congressional inquiry sat unanswered in someone's inbox. That's when Luna went public. November 3rd, she tagged Duffy directly on Twitter. Just sent you a formal letter requesting the 3I/ATLAS data. American taxpayers deserve transparency. The post went viral. The scientific community rallied behind her. Astronomers started openly questioning why China and Europe could share data while NASA stayed silent. November 5th brought a breakthrough. Sort of. Luna confirmed publicly, just had a good conversation with NASA. Images will be released as soon as the government reopens. She announced a formal briefing to her staff was scheduled, though the date remained unspecified. Progress, but vague progress. Except the government already reopened. The excuse no longer held water. Days passed, then weeks. No images, no briefing details. Just continued silence from the agency that claimed transparency was a core value. Luna had done everything by the book, consulted experts, filed formal requests, used congressional authority, gone public only after private channels failed, and still nothing. August 6, 2025. The James Webb Space Telescope, the most powerful infrared observatory ever built, locked onto 3I/ATLAS. What Webb detected shouldn't exist according to every comet model we have. Carbon dioxide to water ratio, 8:1. Read that again. 8 parts carbon dioxide to 1 part water. Normal comets reverse this ratio completely. Water dominates. Ice sublimates as the comet approaches the sun, creating the characteristic tail. Carbon dioxide exists as a minority component, typically less than 20% of the volatile mix. 3I/ATLAS inverted everything. The Comet composition by mass, 87% carbon dioxide, 9% carbon monoxide, 4% water. Statistical significance measured at 4.5 to 6.1 sigma above normal. In statistical terms, this means the probability of this occurring randomly is essentially 0, 1 in millions. This isn't a comet with unusual chemistry. This is chemistry that violates our models of how comets form, how they evolve, how they behave. But the strangeness doesn't stop at ratios. 3. I/ATLAS changed colors 3 times during its passage through the inner solar system. July 2025, distinctly red organic compounds called tholins reflected sunlight, giving the comet a reddish hue common in outer solar system objects. September 7th, vivid green cyanide molecules fluorescing under ultraviolet radiation, a dramatic shift indicating massive compositional changes in the outgassing material. Late October, electric blue, bluer than the sun itself. Carbon monoxide and hydrogen emissions overwhelmed everything else, producing an azure brilliance never documented in any comet, solar system, or interstellar. 3 complete color transformations in a single pass, never seen before in any comet in history. The production rates were equally extreme: 150 kilograms per second of mass loss. Carbon dioxide sublimation overwhelming all other processes. To put this in perspective, only one other comet has ever shown comparable carbon dioxide enrichment. C/2016 R2. That comet was considered an extreme outlier. 3I/ATLAS makes it look normal. These observations came from the James Webb Space Telescope, the Hubble Space Telescope, ground-based facilities, all public, all peer-reviewed, all openly shared with the scientific community. NASA released this data. They published it. They let scientists worldwide analyze the chemistry. So why release the chemistry but withhold the images? The spectroscopy tells us what it's made of. The images would tell us what it looks like. What structural features could be so sensitive that NASA hides them while simultaneously sharing chemical data that already terrifies astronomers? July through August 2025. The Very Large Telescope in Chile, one of the most powerful ground-based observatories on Earth, aimed its spectrographs at 3I/ATLAS. What they detected stopped astronomers cold: nickel vapor emissions. Production rate of 4.6 grams per second. Concentrated within 600 kilometers of the nucleus. Temperature-dependent scaling followed a power law of R to the 8.43. Here's the problem. No iron detected. None. 0 iron signature in the spectroscopy data. Nickel and iron are inseparable in nature. They're born together in supernova explosions. They exist in cosmic materials at fixed ratios determined by nuclear physics. Every asteroid contains both. Every meteor contains both. Every comet ever studied contains both. They're bonded at the atomic level, forged in the cores of dying stars, mixed together for billions of years. Separating nickel from iron requires industrial processes. The Mon process, developed in 1890, is used to refine nickel for manufacturing. It uses a specific chemistry. Nickel reacts with carbon monoxide at low temperatures to form nickel tetracarbonyl gas. Heat that gas to 200 degrees Celsius, and pure nickel precipitates out while the carbon monoxide is released. It's the basis of industrial nickel production. 3I/ATLAS has abundant carbon monoxide, 87% carbon dioxide, 9% carbon monoxide in the coma. It has low temperature conditions in the outer coma regions where sublimation occurs, and it's producing pure nickel vapor without any accompanying iron signature. The only natural explanation scientists can offer is spontaneous formation of nickel tetracarbonyl in space, a reaction theoretically possible but never observed in 4 billion years of solar system astronomy. We're seeing a chemical process that precisely matches industrial manufacturing methods, occurring around an object that's been in space for billions of years. Avi Loeb calculated the statistical likelihood of this naturally occurring, approximately 1 in 100 million when combined with the trajectory, chemistry, and structural anomalies. Critics counter that we simply don't understand interstellar comet chemistry well enough. We've only studied 3 interstellar objects. Maybe nickel-iron separation happens through exotic processes we haven't discovered. Maybe cosmic ray processing over billions of years can fractionate elements we thought inseparable. But here's what keeps scientists up at night. We're not seeing slightly unusual ratios. We're seeing complete separation, industrial-grade purity, 0 iron contamination. It's like finding pure aluminum in nature without oxygen, or pure sodium without chlorine. Elements that don't separate naturally. Either we're witnessing a natural process never documented in the entire history of astronomy, or we're seeing something engineered. Analysis of 3I/ATLAS's trajectory and galactic velocity reveals something that challenges everything. Estimated age between 7 and 14 billion years. Our solar system is 4.6 billion years old. This object could predate Earth itself by 9 billion years. It's older than the Sun, older than the planets, older than anything in our cosmic neighborhood. The velocity components tell the story. Movement toward the galactic center, -51 kilometers per second. Movement above the galactic plane, plus 18.5 kilometers per second. These numbers place its origin in the Milky Way's thick disk population, stars and objects formed during cosmic noon, when the universe was less than half its current age, when star formation peaked across the galaxy, when the building blocks of modern stellar systems were still coalescing. It spent at least 1 billion years, possibly several billion, drifting through interstellar space before entering our solar system. And that journey fundamentally changed it. Galactic cosmic rays pervade interstellar space. High-energy particles from dying stars, black holes, supernova remnants. They bombard everything constantly at near-light speed. For an object spending 1 billion years in this environment, the radiation damage is cumulative and profound. Laboratory experiments show how cosmic rays transform cometary material. They convert carbon monoxide to carbon dioxide through radiolysis, the exact chemistry we're observing. They synthesize complex organic compounds called tholins, creating the red coloration observed during 3I/ATLAS's inbound journey. They transform crystalline water ice into compact amorphous ice, most efficiently in the outer tens of meters of material. The result? An irradiated mantle approximately 15 to 20 meters deep, a radiation scar covering the entire surface. Here's the critical finding. Current outgassing is sampling only this processed outer layer. Estimated erosion depth during the solar system passage, between 15 and 20 meters, matches the cosmic ray processing depth exactly. We're seeing surface material ablating away, but we're not reaching pristine interior composition. The original material from 7 to 14 billion years ago remains locked beneath the radiation scar. Post-perihelion, after the comet rounds the Sun and moves outbound, deeper erosion might expose unprocessed material. But researchers consider this unlikely. The outgassing rates are declining as it moves away. By the time it exits the solar system in 2026, we may never know what lies beneath. This thing witnessed epochs of cosmic history we can barely comprehend. It formed when the universe was younger, when galaxies looked different, possibly before our solar system even existed. And we're looking at its billion-year-old sunburn, not its original surface. Harvard astrophysicist Avi Loeb, former chair of the Astronomy department and one of the world's leading experts on interstellar objects, conducted a full statistical analysis of 3I/ATLAS. He examined everything: its trajectory, mass estimates, chemical signatures, and the bizarre behavior of its jets. His conclusion was simple and shocking. There is only a 1 in 100 million chance this object formed naturally. Loeb's numbers aren't guesses. They're documented. Atlas travels within 5 degrees of the ecliptic plane, where Earth and the planets orbit. Random interstellar objects rarely do this. The probability is between 0.2% and 2%. Add its unusually close approaches to Jupiter, Mars, and Venus, and that probability collapses to 0.005%. Combine trajectory, size, and mass, and you land at Loeb's headline figure, 1 in 100 million. Then come the jets. 7 outgassing streams, some pointing toward the Sun instead of away, producing a 950,000-kilometer anti-tail. No known comet behaves like this. Loeb published every equation openly, inviting scrutiny, not shielding it. Critics tried to dismiss the anomalies as quirks, yet Loeb's data gained momentum because over 50 observatories worldwide confirmed the same patterns. Hubble shared data, Webb shared data, China and Europe shared everything. Everyone shared, except NASA's Mars Reconnaissance orbiter, the one with the clearest view. NASA's HiRISE camera has the power to answer every major question about 3I/ATLAS in a single frame. At 30 kilometers per pixel resolution, HiRISE can shrink ATLAS's uncertain 320-meter to 5.6-kilometer size range into a precise measurement. Even more importantly, it can reveal the shape. Natural comet nuclei are jagged, chaotic, and uneven. Oumuamua was elongated like a cosmic surfboard. But if Atlas appears smooth, or worse, spherical, that alone would force a scientific crisis. HiRISE can also reveal surface features, craters showing billions of years of impacts, smooth regions suggesting resurfacing, or geometric patterns that do not occur in nature. And the jets? Earth telescopes only saw hints. HiRISE could pinpoint their exact origin points and determine whether they erupt randomly or follow a symmetrical engineered layout. The images exist. They were taken October 2nd. Staff returned from furlough. Regular Mars images resumed. But Atlas remains locked away. China's blurry Mars images show something is there. Spectroscopy confirms the chemistry. Light curves suggest structure. But we don't know what it looks like. Representative Luna isn't chasing conspiracies. She's fighting for precedent, because if NASA can bury data on the most important interstellar visitor in history, what stops them from doing it again? Those images will answer everything. The only question now is whether we're ready for the truth.